Okay, so today we're going to be going over the recap for what we went over this week, which is right triangle trigonometry. Okay, let's get started. So last week we learned about similar triangles, which are triangles that are identical in terms of shape, but are different in terms of size. So we learned how their angle measures are always the same, even though their side lengths may be doubled, tripled, or multiplied by some other ratio. So for example, the following two triangles are similar triangles. We see here, have this triangle, A, B, C, and the angles here are X, Y, and Z. And on this triangle D, E, F, the triangles are also, so the angles are also X, Y, and Z. So these angles are all equivalent. Z is equal to Z here, Y is equal to Y, and X is equal to X. So therefore, these two triangles are similar, meaning that even though this triangle is larger, the side lengths will be proportional. And you see that here. For this, so these are the same triangles here. We see how A divided by D, so this side divided by this side, will equal to B divided by E. So this side divided by this side, which is equal to C divided by F. Alrighty, so another review of triangle similarity, we have the angle-angle rule. So this says that if two of the angles in the triangles are the same, these two triangles are similar. We know this because if these two triangles we know, then we know the third angle as well, because we know that all three angles added up will be equal to 180 degrees. All right, so these two will be similar if all the angles are the same, which the angle-angle tells us. Another one here is side angle side. If you know this side, the angle in the middle, and the side next to it, for both these triangles, these will be similar. And again, A divided by C must be equal to B divided by D. So these side lengths will be in a ratio. And lastly, we have side, side, side. This is the simplest of them all. If all the sides are proportional here, so like we went over earlier, this divided by this equals this divided by this, which is equal to this divided by this. That means all the sides are proportional, which means they're being multiplied by all the same number to get to these new side lengths, which means that these triangles are again similar. All the angles are the same, and all the sides are going to be proportional. Right, so thus since similar triangles always have the same side ratios and the same side measurements, same angle measurements, we can set up a series of functions whose input is an arbitrary angle between 0 and 90 degrees. Right. So in particular, given a right triangle and an acute angle that belongs to that right triangle, we define these three functions here. Sine of angle X here will be equal to the opposite side of that angle divided by the hypotenuse of the triangle. Cosine will be equal to adjacent divided by hypotenuse. Tangent will be equal to opposite divided by adjacent. And again, here, angle X is here. So the side opposite from that will be this one. Side adjacent to that, which is next to the angle, will be down here, and that's the hypotenuse of the triangle. Okay, so sine X here. So again, X is going to be this angle right here. So therefore, sine of X will be equal to opposite divided by hypotenuse. So say, all right, next. Cosine equals adjacent divided by hypotenuse, same thing. Our angle is down here. The adjacent divided by the hypotenuse will give us the cosine of this angle. Lastly, same thing for tangent. Tangent of angle X here. Tangent of angle X will be equal to opposite divided by adjacent. And you can remember these three using this thing here, so katoa. So here is sine. It's equal to opposite divided by hypotenuse. Ka is equal to adjacent divided by hypotenuse, and tangent is equal to opposite divided by adjacent. So how does this work? Why does this all work here? And that's the important thing to understand, because we don't want to just memorize these little formulas here. So again, we remember the angle-angle theorem for triangle similarity, right? So we put sine of an angle, let's call this angle A here. That means we define this angle here. So angle A on the right triangle which tells us that this third angle is known because, again, all three angles of the triangle added up will be 180. So you know this third one. And then so for any triangle where we have right angle and angle A, these will all be similar by the angle-angle theorem. And because they're all similar because these triangles are all similar, we note that sine will be the same because sine is just a ratio of side lengths. So let's say A here was 30 degrees. So this makes these 30, 60, 90 triangles. Right, let me label the side lengths real quick. In this case, we're just saying that the smaller triangle, all the sides are divided by 2. So we can see how sine A, remember sine is sa, so which is opposite hypotenuse. So sine of 30, 1 divided by 2, we get 1/2. On the bottom triangle here, same thing, sine of 30 degrees, 1/2 divided by 1, which is still 1/2. Right? So any angle, so when we find sine A, no matter triangle, will be 1/2. So more examples here, let's take a look. Now we have this angle here, we have y, so sine y, again, so opposite hypotenuse, 3 divided by 5. Cosine of y, ca is adjacent hypotenuse, so that's gonna be 4/5. Lastly, tangent is gonna be opposite adjacent. Sorry, yeah, opposite adjacent. Sorry, it's wrong here. 3/4. And so what would sine z be? Let's take a look. All right, it's kind of rotated in a weird way, but sine z, sine is so it's opposite hypotenuse, be 4/5. Cosine, adjacent hypotenuse, 3/5. Lastly, tangent of angle z, which is going to be opposite divided by adjacent, 4/3. Okay, cool. So evaluate the following here. Sine of 30 degrees, we went over this example earlier. 1 divided by 2, opposite hypotenuse, 1/2. Cosine of 60, so we're looking at this angle here, 60. Cosine is going to be adjacent hypotenuse. So 1/2. We'll see here that sine 30 is equal to cosine of 60. All right, cool. Lastly, we're going to go through this one. Again, just some more practice. So sine A, what would sine A be? Take a minute to pause the video here. Sine A, 8 divided by 17. Tangent of A, same thing, 8 divided by 15. And the cosine of B be equal to 8 divided by 17. Okay, so now I'm going to go over a relationship with tangent. So some patterns and some previous answers between sine, cosine, tangent. So since sine is opposite over hypotenuse and cosine is adjacent over hypotenuse, we know that tangent is opposite over adjacent, which is exactly the definition of tangent. In general, tangent is equal to sine divided by cosine. All right, so again, tangent is sine divided by cosine. And what is sine? Remember, sine is opposite. I'll just write O here, divided by hypotenuse. All right, cosine is adjacent, divided by hypotenuse. So we divide these two. We actually just get, so I'll move down here a little bit. Sine, opposite over hypotenuse, multiplied by hypotenuse over adjacent. Again, this is just dividing fractions. Now give us opposite over adjacent, which is tangent. Okay, so those are the basics of right triangle trigonometry here. That's what we went over today. But also a little something else that we will go over in the future is going to be how this relates to the unit circle.